What I do on this channel is to make construction video for civil engineer, architect, and any other person involved in the construction industry. My video also help to client and other people who want to gain one or two knowledge about construction. So in this video, I'll be doing a video on beam rebar arrangement. That's how to arrange the reinforcement in a beam work. So that is what I want to do in this video. Also, in my subsequent video, I've done a video on columns, the reinforcement, the volume of concrete needed for column work. I've done the video on how to calculate that. And probably in my subsequent video, I'm going to be doing for beam quantification for the concrete, the slab reinforcement, how to calculate the slab reinforcement for a job, and for the concreting of this. Okay. So, but today's video is on the rebar arrangement for beam. So in this video, I'm going to cover the layout of the drawing, the section, and I'm going to show you a video on how for you to see how the work is being done. So at the end of this video, if you found it interesting, remember to give me a like, subscribe to my channel, and also share my videos. Join me in the video and let's begin. How to arrange the reinforcement in a beam. This is the layout of the drawing we are going to be using. So this is the first floor layout of the drawing. So you can see how this line represents beams on the structural drawing, and this area here represents the slab. So this 175 mm, let me zoom in. Okay, what you are seeing here is the thickness of the slab, and this is the thickness of the slab as well. This is the thickness of the slab in this area, but we are not working about that. What we want to work on is the beam work. So let me pick one beam at random. So let me pick this beam 104. So this is beam 104. I'm going to use two beams in this video, so we are going to work with beam 104 and beam 110. So this is beam 104. The size of the beam is 600 by 225. That's the depth is 600 and the width is 225, or you can say 230 mm. That is in millimeters. So the beam is a continuous beam, as you can see. So it's a continuous beam, as you can see. It has three support that's sitting on three columns, and it has a cantilever beam as well outward. That is 2.7 meters outward. If you have this two, you are going to get the meter at which is it cantilever out. So the continuous beam with the cantilever. So this is B line 4, 2, and 1. So it has B line 4, B line 2, and B line 1. So when you are on site and you want to do this kind of job, you want to know how to arrange the beam in that, the reinforcement in that beam. The first thing you do is to come to the layout of the drawing, because the layout is the beginning of every drawing. So at this floor now, we are at the first floor. The beginning of the first floor is the first floor layout. That's the first drawing you are going to see. You have seen the layout, where you have beam, where you have slab, where you don't have anything. Like this area, there is a void, you don't have anything there. The next thing, I'm going to go to the detail of the beam, that is section of the beam, to check more detail about it. More detail. Now let me go to the section of the beam and check more detail on the beam. Okay, we have it here. This is beam 104. So this is where we get more detail on the beam. You come to the section. No, that's the layout. And you come to the section. This is where you get more detail on the beam. Now the section is like cutting the beam into two and looking at what is inside. That is what we mean by section. Now if you look at this, you can see is the first support here at the B line 4. This is the second one at the B line 2, and then the last one at B line 1. Then you have this area to be a cantilever. Now looking at the reinforcement, let's start from this cantilever side. Let's start from here. So the drawing says we should run at the bottom first. It says we should run 320 mm reinforcement from this end of this cantilever down to the middle of the second support, or it's going to go beyond the middle of the second support. That's how we do it. Reinforcement, the drawing that says it runs to the second support, but what you are going to do is to run it beyond the second support by, let's say, 300 to 400 mm beyond the second support. Then another 120 mm reinforcement on this area of this cantilever alone. Then at the top we have 420 mm reinforcement at the top that runs from the cantilever down beyond the second support and 1.35 meters beyond the second support. Then we are going to still run another spacer reinforcement, that is 20 mm spacer reinforcement from this particular place again, from the cantilever down to 4.1 meters above 4.1 meters beyond the first support. So that's what the drawing is saying. And one of the things you should note is the stirrup as well. So you have 17 10 mm reinforcement, the bar mark is 0.3 at 150 spacing center to center. So that's just the meaning of what you are seeing here. After that, now when you come to this video, you know one of these has span across this. Then this is telling us that when we get to the second support, we should introduce 320 mm reinforcement at the support here, at the top here. We are going to introduce that. You know, this one of these has span to this area, but when we get to the last span here, this is span, this is another span. So when we get to the last span here, at the bottom first, we have we have 3 16 mm reinforcement from this support here to the other one here. So it's going to go beyond it, just like I said, and we're going to introduce another 4 16 mm reinforcement at the top to support this one at the bottom. Then at the top we have 2 reinforcement that's going to lap with this one that is coming from the other one. So this is the detail. That's what the detail is telling you. So here we have 29 wide, then 0.3 200 center to center. What it means is 29 stirrup, that's 29 stirrup made of 10 mm reinforcement. The bar mark is 0.3. It should be at 200 mm center to center. So I've taken you through the layout of the drawing and the section of the drawing. Now let's go to the video and see how it's being arranged. Now this is the beam 104. Now from the section that I have here, from what I have in the section, now you can take a look at this. You can see that you have 4 20 mm reinforcement and 4 at the bottom. You can see that you have 3 here. When I play the video, you're going to see it. You have 3 and you have 1 on top of it. Let me play the video. You can see you have 3 and you have 1 on top of the 1 is going to stop it because it does not continue, but this continue. You can see the first one stop at 1.4 meters from the first support and the second one continue. You can see, okay, it stopped here. I see, then the second one continue. Now let's go back so we can count the number of stirrup. You check this, we should be having 31 stirrup here as well. Now there's something about the stirrup. If you look at it, you can see that it is staggered. The hook here is facing towards this direction. The hook here is facing this direction. This is facing this direction, and this is facing this direction. You stagger the stirrup. That is a good practice. Have the spacer bar here. You can see the spacer bar to separate these 2 layers of reinforcement. That's it. So at this junction, you can see the 4 16 mm reinforcement that is coming from the other span here, and here we have another spacer reinforcement at the bottom here, at the top rather. So you can see it. So according to the one, we should have 2 16 mm here, 2 16 mm reinforcement. You can see it, and at the bottom we have this. You can see it. Let's see the spacing of the reinforcement as well. Now we are done with beam 104. Now let's do another one. This time we are going to be making use of beam 110. beam 110 we just did for beam 104. So beam 110 is still 600 by 225 beam. It's a continuous beam as well. It has it is resting on the shear wall. It has a support here. It has a support here. It has a support here. The shear wall is supporting it. So, and you have a cantilever here, although the cantilever is not as much as that of beam 104. So, we've checked the position of the beam. So, from the layout, you get the position of the beam. So, there's the position. There's the position, and we need to check the detail of the reinforcement in it. So, how are we going to get that? We are going to go to the section of the beam to get that. So, let me go to the section of beam 110. So, okay, I may add beam 110. So, there's a section of the beam. So, if you want to check the beam, the depth of it is 10 here. You can see 10. So, from the section of the stirrup, let me locate 10. So, 10 from the section of the stirrup is a 600 beam. You look at it from here, same side is a 600 beam. So, you can see the reinforcement on it, the reinforcement in it. So, let's go back to beam 110. So, what we have here, if you start from the cantilever at the bottom, we have a 320 mm reinforcement at the bottom that runs from this cantilever beyond the second support. Then we also have a 320 mm reinforcement that runs from the cantilever beyond to the first support as well. So that is that on this aspect. But at the top, you have a 425 mm reinforcement that runs from the cantilever down to the second column and beyond it by 1.35 meters. Then the second one, we still have 325 mm as a spacer bar at the spacer bar on the top as well. So it is 325 mm reinforcement. It runs from this cantilever to about 4.1 meters beyond this. About 4.1 meters beyond it, and when you come to this, so the stirrup here is 13 stirrup, this is 31, this is 33. Now at this other region also at the top you have 216 mm, at the bottom here you have 320 mm, 220 mm reinforcement with this support, and 3 at the top here. Yeah, this is what that is what the details, the section of the beam is telling us. Now let's go to the video. Let's go to the video and see if it was actually what we have on ground. What we have there is 425 mm at the top. You can see it according to what the drawing says we should do. And at the bottom, I'm sure it's going to be 325 reinforcement. Then at the bottom, we have this 3 at the bottom. So as at the time of taking this video, we are here to insert the remaining 3, but you have 3 here. So you have to, and if you count the stirrup, let me check the stirrup from the detail. You see it is 13 at, this is 13 at 100 mm center to center. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13 at 100 mm center to center. 8. Let's continue the video. Now you can see that we have another layer. This is the spacer bar. You can see spacer in it, and the stirrup as well. The stirrup of this span is 81 at 200 spacing, 200 mm center to center. Yeah, you can see at 200 mm center to center. So, and you can see that the stirrup staggered. Stirrup is staggered as well. So And let me check if you have anything. Okay, and the support here, the second support, you have a 20 reinforcement at the support here, at the top of the support. I don't think I can see that from this video. I can see that. I think it is this reinforcement here. Then when we get to the last panel, you have 216 at the top and 20 at the bottom. You can say, so this is still the reinforcement that runs from the cantilever down to this area. So this is the 20 the single 20 at the support, then 216 at the top here, 20 reinforcement at the bottom, and 4 feet and 2 at the top. Yes, so you can see them here. So that is how the reinforcement in a beam wall is being arranged. So some of the things I would like to add to this video is the stirrup spacing. So just like if the stirrup is 31, you should make sure that the number of stirrup in that span is 31. Like this is 33, you should make sure it's 33. One of the things you should also take note of is that this slab length, they must be binded together very well. Now this is coming from it didn't get to the support of this, so this reinforcement coming, this 4 at the top, must bind this together firmly. That's one of the things you should not joke with the slab length of the reinforcement. Let me go there if I can see it. So now this is coming from here, and you have another one joining it. You can see you have another 2 reinforcement joining it from the other end. So you must make sure that these reinforcements are binded together firmly. You can see it. You make sure they are binded together firmly. And another thing I'm going to give you as a take home in this video is that the bottom reinforcement, you don't lap and expand for a tension reinforcement. No, this is a beam. The beam, the tension zone is at the bottom and the compression zone is at the top. So at this bottom, you don't lap, and that's in the middle of the span. You don't lap in it because the beam tends to deflate. It's withstanding a tension and a compression force. So, and the maximum deflection of a beam occur in the middle of the span. In the middle of the span, the maximum. So if you go and lap at this middle, I've seen some people doing it before because they want to manage the reinforcement and they decide to lap at the middle of the span. No, it is a bad practice. You don't lap in the middle, you lap at the support. So this reinforcement will go beyond this, and this reinforcement will go beyond this support. That's all I have for you in this video. If you find the video interesting, give me a like, subscribe to my channel, and share the video. Thanks for watching.